Yeah, good morning. This will be the third session in computer engineering drawing, wherein if you just remember in the previous two sessions, I had just covered the introduction to projections, and then we have seen what exactly we mean by orthographic projections, and then we built the concept wherein the drawings can be done either in first angle projection or in third angle projection. And based on the concepts what we have built in the previous classes, it is required for us to continue with projections in various aspects, because generally we are interested to draw the projections of an object, because generally that's what we are interested. But before going for an object which is having a three-dimensional figure, now we will start with a very simple case. Now that is the reason, if you just see our curriculum, in the curriculum we have divided this particular syllabus into projection of points, then we will be dealing with projection of lines, then projection of planes, then we have projection of solids. That is, before going to projection of points, we will just see how exactly we are going to do these orthogonal projections for projection of points. So this particular class is dedicated for this projection of points. Okay, if I say point, so what do you mean by a point? So I can just say a point may be situated in space. Now since a particular point may be situated in a space, this particular point may be in any four quadrants, which we have seen in the previous case. Let me say that a point may situate in the first quadrant, or it will be the second quadrant, third quadrant, or in the fourth quadrant. If I say a point is in first quadrant, so what do you mean by that? If I say a point in the first quadrant, means that particular point is above HP and in front of VP. And if I say point is in second quadrant, then we know that point is situated above HP and behind VP. And if I say point is in third quadrant, then we know that point is behind VP and below the HP. Finally, if I say point is in fourth quadrant, then we know that point is in front of VP and below the HP. Now, I am going to illustrate how exactly we are going to get the projection of points once it is situated in all these four quadrants. Okay, now let us start with a point is in first quadrant. So for that particular purpose, I am just going to illustrate by considering, because anyway you know that we are interested to draw the top views and front views, and since I want to draw the top view and front view, we need to consider two principal planes of projection. One is VP, another is HP. So let me just indicate. So you can just see that I just consider, and of course we know that this is the position of the observer wherein it is observed from the front. So vertical plane, then we have this horizontal plane. Of course these two planes are perpendicular to one another. Now I want to consider let us say a point A situated in the first quadrant. So let me get that. Okay, so let me say that we have this point A. I have this point A which is above HP. So above HP by what distance? I will just consider, let us say consider this distance to be some h. I can say the point A is above HP by distance equal to HMM, and this point A is also in front of VP. How much it is in front of VP? That also can just indicate here. So let me say that this particular distance is indicated as D distance. Always remember, as a customer, always I will take H distance with reference to HP and D distance with reference to VP. Okay, now as usual we know that we are interested to draw the projection of this particular point A. So how do you do that? Again, we have the observer. So observer has to do this, then he has to draw the projector. And we know that the projector has to be perpendicular to this particular plane. Let me say that I have just drawn this particular line, then it is going to disappear. And this particular point is A dash, because by convention, I told you that whatever the project on vertical plane, it is front view, and the front view generally indicated as A dash, B dash, etc. Okay. Similarly, if you look from the top, so top in the sense, I am moving from above. So if I view from the above, this is point A, then it has been projected onto the horizontal plane. So once it is been projected to the horizontal plane, we got this point as A. Okay, that will say that I have projected this point A in both in the vertical plane as well as on the horizontal plane. Now, if we just see this particular figure, what is this distance we are getting here? Because this distance is same as this distance. So we say that this distance is h distance. This is h distance, and similarly, this d distance is with this distance. D distance. Now, what I am supposed to do now? So, as I told you in the previous sessions also, we need to rotate. So, which plane we rotate? If you just remember, always you should remember that we need to rotate this HP such that your HP will be open such that the first quadrant will get open out. That means you say that I am going to rotate in this way. So, once I open like this, what will happen to its top view? Top view will come below the front view. Is it okay? And what about these lines I am getting? Because anyway I said that this is a projector which is projected from the front view. This is a projector which is projected from the, when I view from the top. Now since that is the case, these lines, they are nothing but projectors. And once I rotate this plane, these two projectors were perpendicular to one another. But once I rotate this, they will also become a line perpendicular to XY line. Of course, XY line is the reference line which is the intersection of both HP as well as VP. But anyway, you are not supposed to do like this. You are supposed to show in the orthogonal projection. So what is the orthogonal projection? I will draw the XY line. So XY line is the intersection of HP and VP. Then the front view will be above XY line. So let me consider this distance and put it here. You can just see this. I am just getting this. This is point A dash. Then I have this distance which is D. I am going to get here. So I am going to draw this line. So this is point A now. Then this distance is, what distance here? H. This is H distance and this is your D distance. And once you draw these projections, anyway we are interested to show the projection of points only. So these are the points. So I can say A dash is the front view of point A, and A, small a, will be the top view of the point A. And then since these lines which are joining top view and front view, always remember whenever you draw the projections, your projector should have A dash and A, or I can say the line joining the front view and top view will give the projector. And what about these projectors then? Since these projectors are not the purpose for me, purpose for me is to draw the projection of points. So since they are projectors should be as thin as possible. So just indicate here. So these are the projectors, and these projectors has to be thin lines. Remember, you should not direct this because this should be as light as possible. But this you can just show it as a star like this, which indicates that this is A dash, this is A. So now we can see this is the projection of the point when the point A is in first quadrant. Now let me consider that the point is in second quadrant. So what do you mean point in second quadrant? If I say point in second quadrant means the point is behind VP and above HP. So let me show that. So let us see that. Again, you can see this is the front position wherein the observer has to stand. Now, with reference to the observer, as usual, I can say this is VP, and again, as you can see, I just extended this because if you just remember in the previous class, by extending this vertical plane, horizontal plane, either direction, we are going to get the 4 quadrants. Okay, so this is an extension of this HP here. Okay, this is VP and this is HP. Now, let us say I want to consider a point B. So, point B is in second quadrant. So, what will be point B in second quadrant? That we say that point B is behind VP and above HP. So, let me show that. Let us say I am just considering a point here. Let us say this is point B. Okay. Now I can say this point B is above HP. So above HP by what distance? So this is the distance. And this point B is behind VP. Behind VP by what distance? By this distance. Is it okay? Now as usual, the procedure is what? I need to project this point B onto the corresponding planes. So if I look from the front, I am just going to project that particular point here. Let us say I am going to get some area. So this is point B dash, that is the front view. Now if you look from the top, as usual from the above, this is the point B. Okay, now as usual I can see this distance is H distance and this distance is D distance. Now what is the next procedure? I need to rotate the plate. So how do you rotate the plates? Again I took the same convention. So what is the convention I said? Always while rotating the planes, first and third quadrant should open. Now anyway now there is no first quadrant here. Now we have third quadrant on this side. So what I should do then? If I rotate this plane, see when you see this, see you would have extended this plane here. If I extended this, I rotated this like this will move above. So like that, you can see in this particular figure, this particular plane will rotate such that it will be in line with VP. Is it okay? So I can conclude that wherever we have an object in the second quadrant, both top view and front view will come above XY line. Okay, now let me draw it. Now anyway, I am interested to show it on a XY line, ortho projections. That is, again as usual I will draw the XY line. I draw the XY line. Then, both top view and front view is above XY line. So I will take this distance. This is H distance. So let us say H is somewhere here. So let me take it deeply. XY, I will take H distance here. Again a light line, remember. So this point is B dash, then B. So where do you get B? B will also come above XY, right? By what distance? By distance D. Let us say I am going to get D somewhere here. Is it okay? Then I told you that the line joining B dash should be on the same projector. That is the reason even if I rotate this particular line will coincide with this particular projector itself. Okay. So I can show this distance is, always remember with the HP distance is always indicated as H distance. And VP distance is always indicated as H distance. That is height. So you can see in this particular case, both top view and front view will come above XY. Let us say if the point is in third quadrant, now I need to consider again these planes. So let me consider Is it okay? So this is the third quadrant. So HP, VP and the position of the observer. Now I want to consider a point, let us say C. Okay, so let me indicate that. Okay, now let me say that this is that particular point C I am interested. Now we can see this point C is below HP. So below HP what distance? I can just indicate this. So below HP by a distance equal to H. And it is behind VP. Behind VP by what distance? This distance. Is it okay? Now as usual, I need to project these points onto the corresponding planes. So if I look from the front, so this is a point. So it will pierce here. So you know that we need to consider these planes to be transparent. So that this will be the point C dash because of front view, because it shall be projected onto the vertical. Remember, always on vertical plane you will get the front views. Okay, now if I look from the top, then I am going to get the point C. As usual, you can see the plane will come in between. That's what I used to say. Is it done? So this point is C. Now what you do now? I need to rotate the planes. Which plane you rotate? Always remember, we always will rotate the HP now. That is, HP is rotated such that third quadrant is opened up. That means to say that I need to rotate this in the other way. So I need to rotate like this. So if I rotate this plane like this, what will happen? Once you rotate, you can see that top view will be above the front view. Okay, that means that top view will be above the XY line and front view will come below the XY line. So again I am going to show that. So let us say this is my XY line as usual. So again XY line is the intersection of both HP as well as VP. Now again see this distance. So what is this distance? This distance nothing but D distance. So I can say this is D. What is this distance? H distance. So once I rotate, what will happen? Your C will come here. So that distance is equal to what distance? It should be equal to your VB distance. Okay. So VB distance I am just showing here. C projector should be light. Then I am going to get C dash. So this distance will be D. And this distance will be H. Okay. Now let us consider point is in the fourth quadrant. That means the point is below HP and behind VP. So let me illustrate that. Just see that I am just considering the fourth quadrant. So fourth quadrant again, the observer is as usual here. This is HP, horizontal plane, and this is vertical plane. Now let me consider a point which is below HP and in front of VP. So let me consider that. Let me consider we have a point D. So point D is behind, in front of VP. By what distance? You can just see this. This is that particular distance. So this is I am measuring from VP. So VP distance I told you always we consider that to be distance D, and this particular point D is below HP. By what distance? This distance. that is h distance. Now as usual, I need to project this particular point D on the corresponding planes. Okay, now if I look from the front, so this is my position of the front. If I look from the front, then I am going to project it onto the vertical plane. So it is intersecting this plane at this particular point. So I will get this point to be D dash. If you just look from the top, the point will come here. So let me consider this as point D. Okay, now as usual, I need to rotate the planes. So if we just rotate the planes, how do you rotate the plane now? Always remember, while rotating the planes, first quadrant should open up. But anyway, the fourth quadrant now. So first one open up means I need to rotate in the downward direction. That is, I need to rotate in the clockwise direction. So I am just going to rotate in this way. So once I rotate, now we can see that both the top view and front view will come below xy line. So let me indicate that. So I will draw this xy line. Then both these distances will come below xy line. Of course, projector should be on the same projector. Both top view and front view should be on the same projector. Let us say this is point D. Let us say, this is point D. This is point D dash. And the distance what I have taken is, I have taken this distance as D distance. I have taken this as h distance. Okay. Now we have just covered by giving these illustrations when the point is in different quadrants, how exactly we are going to get top and front view, and always you can just remember, depending upon which quadrant a point lies, its top view and front view relative positions will change. Now you can make a common analogy, or if you just make a common conclusion, if you just observe all these figures. Okay, and always remember, whenever we look from the front, which description we are going to see, I can always see with reference to HP I can see. That is, whenever I look from the front, always I can visualize the HP distances. That is, how much it is here. That may say that anyway we know that with reference to HP, the object may be either above HP or below HP. Okay, that means in the front view, we can visualize only this HP details. That is, with reference to VP, I cannot say anything. See, if I look from the front, I cannot say whether the D distance is this much or whether it is more or less, whether it is here itself, I cannot make out anything. That would say that if I look from the front, we can get only HP details such as H distances. But whereas, if I look from the top, above, so since I am looking from the above, I can make out only the distances from the VPs. That means I can say whether the point is in front of VP or behind VP. But whereas with reference to HP, is it possible for us to visualize? Because if I just view from the top, this point may be anywhere. So it may be a HP also, which I cannot view. So always remember, wherever we have these details, if I look from the front, we see only H distances. Whereas if I look from the top, I can see always the details of VPs, that is D distances. Okay. Then further, if you just see all these four figures, in all these four figures, if I say this is my first quadrant problem, I said this is my first quadrant. Okay. So this is second quadrant. Then I said this is third quadrant. Then I say this is fourth quadrant. Okay. Now, if you just see, if I say point is above HP, so in which cases you will get the point is in above HP? Which cases you will get above HP? That is either in first quadrant or in second quadrant. Only in the case of first quadrant and second quadrant, I can say point is above HP. Whereas, if the point is below HP, where do you get that? It may be either with reference to third quadrant or fourth quadrant. Now, if we just observe this first quadrant and second quadrant figures, okay, by observing this first quadrant and second quadrant orthogonal projections, you please tell me when the point is above HP, what about the front view? Okay, just see this front view is above XY line. Here also front view above xy line. Why it is above xy line? Because the point is above HP. Since the point is above HP, I can now say front view is above xy line. Okay, now tell me about when the point is below HP. If I say point below HP means either the point may be in third quadrant or fourth quadrant. So that means to say that if I just see this this figure and this figure, if we just see those two figures, what about the front view? So front view is below xy line. That means what the general conclusion I can make? I can say that if the point is below HP, front view will be below xy line. So I can make one statement regarding front view. What can I say? I can simply say if point is above HP means what? Front view is above xy line. Is it clear? Similarly, if point is below HP, I can say front view is below xy line. Is it clear? Okay, now tell me regarding your top views now. Now again, if you want to say top views, we know that top view means always we need to know only VP details. That is, in the top view, I will get the VP details. That is, the point is how much, your point is how much from, D distance how much from these planes. That's what I am going to see. Okay, now tell me, if I say that point is in front of VP. So in which quadrants you will get point is in front of VP? I will get point in front of VP in first quadrant as well as in the fourth quadrant. Is it okay? Now, if you just see first quadrant and fourth quadrant top views. So you see the first quadrant top view, where you are getting? I am getting below xy line. And again in the fourth quadrant, where I am getting top view? I am getting below xy line. So what is the conclusion I can make now? I can now say that if the point is in front of VP, its top view is below xy line. Now, okay, similarly, if I say the point is behind VP. So in which cases I will get the point is behind VP? Either it can be in second or third quadrant. Okay, now just see the figures. In second quadrant, where do you get the top view there? Above xy line. So what about the third quadrant? Above xy line. So what is the conclusion I can make now? That is, if the point is behind VP, then the top view will be above xy line. So if I just make that statement, if I give any problem to you, you can just do this. Understood? So I am just going to write that if point is in front of VP. So what I should write now? If the point is in front of VP means top view is below xy line. Okay. Finally, if I say the point is behind VP, if I say point is behind VP means then top view is above xy line. So I think you have followed this. Okay, now you can make. And whenever you have any problem, you can just remember this. And always remember, finally I am going to tell you, in the front view, we see HP details, and in the top view, we see VP details. And also remember, wherever or the line joining the top view and front view should be on the same line, and that line is known as a projector. And that projector should be perpendicular to XY line. And remember, this projector should be drawn as light as possible. Yeah, just to explain that a point may be situated in any of these quadrants, but it is also possible that a point may be in one of the planes itself. Somebody say that a point may be in HP itself, a point may be in VP itself, or a point may be in both HP and VP as well. So let us consider these three cases. Now let us say a point is in HP. So what do you mean point is in HP? I told you that if I say point in HP means this H distance should become 0. See, if H is equal to 0 means what? Always H indicates the distance of a particular point above HP. If H is 0 means the point should be on HP itself. That means H distance is 0. Let us say I am considering this point. Let us say this point is E. I am considering point E on HP. Of course, it is in front of VP. By what distance? I will consider this. Let us say this is the distance. It is in front of VP. So what is the distance we have considered for VP? It is D. So let me consider this also as D now. Okay, now I want to draw the projection of this particular point E. So now again I am looking from the front. If I look from the front, since this H distance is 0, where do you get this point E then, or E dash then, front view? It should be on X1 line itself. So I am just going to draw this projector. Then this itself is point E dash. E dash. And if you look from the top, where do you get point A? I will get point A itself. That is the top view point over here itself. Now if I want to draw the projection of that particular point, so as usual, I will draw the XY line. XY line. Then I will get E dash on XY line, and the D distance I will get here. So this is point D and this distance is D. So that will say that when the point is in HP, front view will be on XY line. Okay, now consider the next case. Now let us say that point is in VP. If I say point is in VP means its D distance should be equal to 0. So D0 means, let us say I will consider some area. This is your point. Let us say some F, capital F. So capital F is the point which is in VP itself. And since it is in VP, its distance from HP, you can have some distance. Maybe this particular point F may be above HP. By what distance? Let us say this is the distance H. It is above HP by by distance H, and point is in VP. Now as usual, if I want to draw the projections. So how do you do the projection? Let us say I will look from the top. If you look from the top, and always remember, in the top view, we see VP details. Now anyway the D distance is 0. Since D distance is 0, we expect that the top view point of F should be on XY line itself. So I will get this point here. F. Then, if I look from the front, I know that this particular point F is above this HP by distance H. Always remember, HP details will be seen in front view. Is it okay? So I need to draw the point. Let us say this is F. F dash. And this distance is equal to what distance? H distance. Now finally, let us say we have a point somewhere here itself. Let us say this point is G. What about this point G? G is not only in HP, it is also in VP. That will say that this point G is in HP as well as VP. That will say that its both H distance and D distance are 0. Since they are 0, if I look from the front, where do you get the corresponding front view of this? On XY. So here itself we will get G dash. And again if I look from the top, so where do we get, because VP distance is 0. So top view will also be here itself. That is I will get G here. So that in the ortho projections, I will simply mark a point. Here I will show G dash and G. Is it clear? Now I can simply say that whenever a point is in a particular plane, then its projection on the other plane will be on XY line. So it is as simple as that. That we say that if the point is in HP, its front view will be on XY line, and if the point is in VP, its top view will be on XY line.